live. Good morning, good evening, everyone, depending on where you are. Welcome back to the Topos Institute Colloquium. I'm Kevin Carlson, covering for David Spivak. I think he'll be back next week if you're missing David. And we are very excited to welcome this morning Dan Ghica from Huawei and the University of Birmingham, speaking on some programming languages work. We're very excited to hear about this as we've been doing some programming languages flavored work for the first time at Topos. So hopefully you can give us some good tips, Dan, whenever you're ready.
Okay, hi. Thank you for inviting me. It's an honor to speak here. And let me tell you a little bit about how this talk is going to proceed. It's first of all, it's not going to be very technical. It's going to be quite informal, and it's going to be more of an experience talk. And because it's informal, feel free at any point to add questions and comments, observations, and so on. Because it's something that I think it's something that can give a fairly unique perspective from the point of view of somebody who worked a long time in theoretical computer science, programming language side, and now it's working on in the industry on actually developing an industrial strength programming language. First of all, some disclaimers. Even though I'm an employee of Huawei, right now I don't speak as an employee of Huawei. I speak for myself. Anything that I say cannot be understood as an official statement for commitment or promise or anything to do with Huawei. It is solely my personal experience. And if I say something that sounds like some kind of plan or some kind of promise, it should not be ever taken as a guaranteed. And I know this is going to be posted on YouTube, which is fine, but I think I don't want anything to be particularly taken like chopped as a fragment of my talk and posted elsewhere. If this talk is going to be posted anywhere, please post it in its entirety and consult me before so I can approve of it. With this out of the way, so why it makes this talk interesting is because I worked for more than 20 years as a academic, and I had only, let's say, an imaginary connection with the world of industrial programming languages. And so it happened that around 2019, the end of 2019, I was contacted by a company who said, would you like to use your expertise in programming languages to work for us and help develop a completely new programming language? So this was me then, this is me now after undergoing the trauma and excitement of working for 5 years on a project concerning the development of this new programming language. And yeah, I think my expectations when I joined, they were absent, I would say. I joined with an open mind. I didn't know what to expect going from academic to position to an industrial position. And also, my transition was not complete. I'm still 20% professor at the University of Birmingham. I have a research group there. I still publish a regular research paper as before, mostly with the help of my research group. But most of my energy and my time is devoted to this work in the industry. So I think this is the perspective that I want to give. It's not the perspective of somebody working in the industry, but it's the perspective of an academic, fairly theoretical background working in industry. So how it all started, around 2019, I was contacted by a recruiter. He said, would you like to work in industry for programming languages? And I thought, well, that sounds exciting. I've been doing this for 20 years as a theoretician. Maybe I can now try my hand at practical thing. I didn't know what company that was. There was some preliminary rounds of discussion, first with a recruiter, And then eventually I was interviewed by the company, which I found out it was a Chinese company called Huawei. I didn't know anything about Huawei at the time. I looked it up in Wikipedia. What I saw, it was a telecommunication company. I was very surprised that they had interest in programming languages. And through the course of several rounds of interview, they convinced me that indeed they had a very serious project of designing a new and mainstream programming language, a programming language that's meant to be used by millions of developers. And what I found out is that Huawei is a massive company. The research budget of Huawei every year runs in the tens of millions of dollars per year. It is on the scale of Google or Apple in terms of research investments. And it's also fully integrated. It does everything from designing and building integrated circuits, operating systems, mobile phones, apps for the mobile phones. And now there's a programming language which can be used to kind of, programming language was the missing link to have a very smooth vertical integration from the silicon all the way down, all the way up to user apps. What I found out very quickly after joining Huawei is that in terms of the hardware that it produces, Huawei is a extraordinarily accomplished company. So here, maybe you have seen videos in YouTube. Mostly these devices are not available for purchase outside of China unless you go to considerable effort. So this is a double hinged phone that opens up into the size of a tablet, and it's fully created by Huawei, from the physical hardware to the chips inside to the operating system to the apps and so on. And this is not the only thing. Huawei is basically constructing or building everything that is computer based. So here, more recently, in the last couple of years, Huawei has expanded greatly and became a leader in China in automotive. So this is a Huawei branded car called Maestro, which is a very high-end luxury car. And indeed, the level of performance and luxury are astonishing, and the level of the value and the price are really quite incredible. So I thought, like, yes, that's a very impressive company, but I was truly impressed only when I traveled to China the first time. And I actually ended up spending a lot of time in China and traveling a lot to China. And I have seen some of the extremely impressive research centers that Huawei has in China. So here on the left is the brand new, opened only a couple of years ago, Shanghai Research Center, which has workspace for about 30,000 employees. And here on the right is the slightly older, so it was open around 2019, research center in Dongguan, also about the same size, about 30,000 people. This here on the left looks maybe how you would imagine a generic research center of a tech company. But here on the right, this research center was created by a leading Japanese architecture company called Nikken Sekkei. And they had this rather crazy idea to create a campus that's formed of 12 villages, and every village is built in the style of a old European city. So this is the village which is built in the style of Prague, a village in which I lived for about a month a few years ago. And indeed, it was a fairly extraordinary and I would say surreal experience, which it was very difficult to get used to be in China and spend your day in such a environment. So this was the company, and this is kind of the just give you maybe some idea about the size and the scope of the company, particularly in China. What I have been working on since I joined is a new programming language called Cangjie, which it's also called, I'm also referring to, or people refer to it as CJ. And this is connected to a very important effort of Huawei to create a new mobile operating system called HarmonyOS Next. It's a fully in-house developed operating system, completely new code base, and a version of it, it's open sourced called Open Harmony, and distributed in kind of controlled, overseen, and distributed in China by the open source foundation on Atom. And there is also a version of it distributed in Europe called Oniro, which is exactly the same code, but it's in Europe, it's overseen by a different open source foundation called Eclipse. You may have heard of it because it's also the one that oversees for a long time, the Eclipse IDE, and it is the largest open source, the largest open source organization in Europe. Cangjie is one of the two programming languages of HarmonyOS. And HarmonyOS is primarily intended as a mobile phone app, but in fact, as a mobile phone operating system, but in fact, it's better to think of it as a universal operating system because it's the same operating system that runs on laptops, on servers, on mobile devices, such as on wearables, such as watches, or on cars, on automotive systems. So the same app will be able to run on all these platforms on this HarmonyOS operating system without adjustment. The other language, and sadly the main language, the original language of HarmonyOS Next is JavaScript, or rather a version of TypeScript called ArcTS. But we are the compiled language. I'm not going to talk about this language too much. I'm just going to later on talk about some of the associated research projects with this language. But if you are interested in the language itself, there is a talk that I gave recently, which you can watch on YouTube at the Open Source Conference in Paris. And also there is a website, and the website will take you to the GitHub repos where you can find the source code, because everything about the operating system and the programming language is open sourced, including its runtime, including the compiler. Everything is open source, so you can both contribute to it if you are excited about it, or you can use it without too many concerns. Any questions?
Does Huawei have a large code base that I assume, since they were such a big company on so many platforms and things for some time, is it one of the goals for the language to be able to enable a transition of all of the existing code base to the new language?
That's an excellent question. I think transitioning is I could give like a whole talk on that. There are several strategies for transitioning. Right now, the ecosystem and the open source community in China is indeed very large, because of various reasons, in which patriotism is not the least of them. The language is quite popular in China, and it has already been picked up by more than 100 Chinese universities as a teaching language. And the ecosystem in terms of open source repos and apps and so on is quite large and growing extremely fast in China, but we are only starting to build the ecosystem in the West, because the people in China, they don't use like the things that we used to, like GitHub. They have their own version of everything. So part of our development strategy in the West is to port as much of that code, because it is open source, but it's just difficult to find because there's a lot of the documentation and all that is in Chinese. So in fact, one of the things that the Oniro Foundation does is when they copy the code, because they take all the code from Open Harmony and they move it basically from Chinese repos such as Git code and Gitty into GitHub, and in the process they make sure of two things: first, that the documentations are all translated into English, and second, that there are no IP concerns. Okay, so what are some of the personal experiences that I had as a researcher in this project? So the nature of the work every year changed. When I joined in early 2020, under quite I would say inauspicious circumstances, my first day of work at Huawei was also the first day of the national COVID lockdown in England, and also the first day of my post-COVID recovery, because I had COVID just before joining. So the way it started was a bit difficult, especially since my task was to create this team that did not exist before me. I was the original, I still am the founding director of the team. So all that had to be done remotely, which was very challenging, learning a lot of stuff remotely. But what was really, really cool at the beginning, when you just start such a big project, is that there is a lot of room for experimentation. And I was very keen on I was very keen on string diagrams, and I still am very keen on string diagrams. And one of my first kind of things that I was quite convinced when I started developing the compiler for Cangjie was that string diagrams are in fact a fantastic intermediate representation for a programming language. I thought the conventional representation as a tree, like abstract syntax tree, had a lot of disadvantages, and the representation as a string diagram overcomes structurally all these disadvantages, particularly in a language that has functional features such as CJ. So it has closures, it has high order functions, and so on. So a lot of the early work, I would say the first couple of years, was spent on implementing and developing a string diagram-based intermediate representation for Cangjie, and that actually went into the compiler. And a lot of my experiences are summarized in a long, about 150 pages paper, which is going to appear as a booklet in Cambridge University Press any day now. It's held up by the fact that it has too many diagrams, and apparently having a book with too many diagrams, it raises all sorts of legal difficulties nowadays because of accessibility requirements. So as soon as these legalistic concerns are overcome, the booklet should appear, but you can read it on archive, a free version of it anyway, which gives a lot of background about how to use kind of the theoretical background of what you need in order to use string diagram as an intermediate representation for a programming language, and looking at things that are really practical, like how to do type inference, how to do closure conversions, how to do various compiler optimization, and so on. But the most important application that really motivating us a lot into using string diagrams is because we wanted to have native support in the language for reverse automatic differentiation. And reverse automatic differentiation, there is a well-known algorithm called Lambda, the ultimate backpropagator, which everybody's implementing, but nobody has proved correct. And in this paper here, with collaborators from my team, we showed that this algorithm is indeed correct using its implementation or its representation in terms of string diagrams. And that was the first time this algorithm was proved correct. I was a little bit surprised that this fact was not met with a little bit more enthusiasm, because it is a widely used algorithm, and we now can show that it's correct. And the reason why it works on string diagrams is that string diagrams, by moving it into graphs, makes the bookkeeping of keeping track of variables a lot better organized. So it allows you some proof techniques, some induction techniques that are very straightforward, and they just don't work on the textual representation because of issues of binding, interaction between binding and substitution and rewriting, which are very difficult to track. And once you move to graphs, you don't have to track them. So that was really cool. And in the process, we had to do some more foundational work on string diagrams. For example, doing something that everybody thought was rather straightforward, or even that it has been done before, such as doing string diagrams for non-strict monoidal categories. It turns out it is not super hard, but it's something that has to be done, and it's not entirely trivial either. So that appeared at CSL in 2023. Work with Fabio Zanassi and his student at the time, Paul Wilson. So again, it was quite nice to be able to do things that are fairly foundational, but motivated by very practical concerns, because a lot of the way you use a string diagrams in programming language, it has to be non-strict. It's like programming languages are not, the product in a programming language is not strict. So yeah, you have to work these details out, and it is quite a lot of fun to work out, knowing that the motivation is really strong. And also pushing it to closed monoidal categories, which was something also new. I think there were some proposals and some sketches of doing closed monoidal string diagrams for closed monoidal categories in some papers by John Baez, but the details were not worked out. And in fact, it turns out that kind of his suggestions were a bit of a dead end. We could not pursue them, particularly because we wanted our string diagrams to get concrete representation as graphs, or rather hierarchical hypergraphs, which can then be subject to graph rewriting using DPO graph rewriting. So that imposes some sanity constraints on how you write your graphs. You cannot just kind of come up with something completely arbitrary, because otherwise they lack the DPO structure, which enables graph rewriting. So again, that was also something really nice. And all these, so this, the reverse automatic differentiation, the non-strict monoidal categories, the closed monoidal category string diagrams, they are all can be found in this extended, let's call it an extended tutorial introduction to string diagrams for functional programming languages. Any question about string diagrams? Because that's probably the most category theory that I'm going to mention in the entire talk. And I know this is a fairly category theory-oriented crowd.
So may I ask, are you also doing higher rewriting? So are you, for example, considering the two-dimensional cells in these graphs or even higher structures?
Yes, because you have, like, if you do beta reduction, you have to do that because you have to pop one of the bubbles.
Yeah, very nice.
So yeah, this is all, the technical details are here, and the introduction is available in the, kind of a more tutorial introduction is available in the other paper. Eventually, the string diagrams as included in the compiler gradually evolved into something unrecognizable. And the reason was determined by practical contingencies that we couldn't keep up with. So initially, the idea was very neat that the string diagrams are going to be an intermediate representation used primarily for data flow analysis, for which they are perfect. And then there's going to be a control flow analysis further downstream in the next stage of the compiler. But of course, there are advantages of doing control flow and data flow analysis simultaneously. And we had some really nice ideas, which someday I will get around to publishing it, of doing control flow analysis on the string diagrams and compositionally and with very high degree of precision. So all that was very nice. We could have some really, really powerful optimizations. But compared to traditional techniques that you find in the textbooks based on SSA form, our algorithms were too slow. So the compile time was too slow. Even though the code was optimized and the algorithms were very neat, the optimizations were very powerful, the compile time was too low. And that's something that takes you by surprise as an academic. You don't, like, when you think about code, writing a programming language and the compiler and all that, you don't really lose a lot of sleep over compile times. But in fact, it ends up, for many people who are users, the compile time can be a deal breaker. And on a very large project, I mean, the thing is with the compile time on small projects, whether something takes like 1 millisecond or 10 milliseconds, you don't feel it. But if you amplify the same scale to a large project, so instead of 1 day, because we did have code that was so large that it took 1 day to compile. Now, instead of 1 day to compile, it takes 10 days to compile. Then that's obviously, people cannot work with such a cycle. So in order to make them more amenable to textbook algorithms, yeah.
Just a question on this one, because I mean, of course, compile time is very important and stuff like that. But what exactly did you use as the bespoke best time so that you kind of said that your version was not living up to it?
Oh, some of these large projects were already implemented in some other languages, and they were converted to CJ. And people knew how long it took their old compiler, and they expected the CJ compiler to take a similar amount of time. They were not, but and they wouldn't care if instead of 10 hours it takes 12 hours, but if instead of 10 hours takes 10 days, then they wouldn't like that, and they say we cannot use this stuff.
Right, but you don't want to tell who kind of was that you.
Oh no, this was all internal. This was very early on, and these were internal users porting existing code
from other people.
yeah, from other compilers to our compiler.
I see.
So this was before it was publicly released. The compiler was only open source this year, actually. It was announced and distributed with binaries last year. Sorry, not in 26. So it was announced and distributed with binaries in 2024 and open sourced in July 2025.
Right.
By that time, the string diagrams, the string diagrams as we envision them, the way they're used in the compiler is not really, I would say, really recognizable anymore.
Thank you.
The code has not been removed, but so much stuff is added that I would hesitate to call them string diagrams anymore. In the early days, we worked on a lot of really interesting things, such as I mentioned, reverse automatic differentiation. We also worked on a version of Cangjie that had native support for probabilistic programming. We eventually abandoned all these things for practical reasons. So here, what you see in this picture is an Olympic diving pool in Athens. So there are some things that take a lot of effort to build, and it's very nice to build them, and maybe they get the one-shot use. But after that, worry is that the actual user base is going to be oh, what happened? Uh-oh. Okay. The actual user base is going to be too small to justify maintenance. And some features such as reverse automatic differentiation and probabilistic programming have such a broad footprint in the compiler that anything that you do in the compiler requires special maintenance for these features. So they were, even though they were very interesting, we moved away from them. And that also kind of taught me a harsh truth of industry activities, that impact is everything. If something is not going to be used by a lot of users, it's not really worth doing, even if it seems to be very exciting from a technical point of view. So these were some of the things that we researched. We invested a lot of effort into them. We had actually good solutions, but they were nevertheless abandoned because they were not thought to be enough of a potential user base.
Dan, there was a question in the chat from Giannis.
Yeah, that's what I tried to, but when I clicked on the chat, the whole sharing thing
that's when okay. So Giannis
went
asked,
out of whack.
Giannis asked, is there a correlation between compilation time and algorithmic performance, or could one get insights on how to speed up the running of the code from how the compiler handles it?
Oh, that is very difficult to say because the compiler is so, is so complex. It's just that it's just that I think the one thing that was problematic with our string diagrams based approaches is that we spent a lot of time worrying about composability. So kind of composing the control flow analysis instead of rerunning the control flow analysis. But that, in fact, was not, the cost of these operations was not big to begin with. What was expensive was the fact that our optimizations required several passes. And with SSA-based optimization, you can do really powerful optimizations, not as powerful as we were doing, but almost as powerful, but with a single pass. And I think going from single pass to multiple pass, that makes a big difference. Because if you have only a single pass, obviously you have less time because you only do one pass, but also you can save memory. You don't have to store things because they're only going to be used once. You can throw them away as you build them. So multiple pass, that was the problem. Multiple pass introduces very big performance penalties. Something that in hindsight seems probably obvious is like, duh, of course, but at the time it didn't. Because as I said, on small examples, you don't notice it. You only notice it when you move to really large examples. Now, something that's exciting and it was successful is effect handlers. So other than OCaml, I think it's safe to say that CJ is the only widely available industrial strength programming language that has effect handlers. They are still yet to be, they're going to be merged at some point in the main distribution, but you can get them in the, as it were, in the nightly build of the language, not in the long time maintenance build of the language. And that was a very interesting experience. Personally, I had no research experience with effect handlers before I joined Huawei, but Edinburgh is a hotbed of effect handlers. They were obviously invented here by Plotkin and Power, and there are still here world-leading scholars of effect handlers such as Sam Lindley, such as Ohad Kamar. And by talking to them all the time, obviously they had an influence on me. And then I realized, hey, these effect handlers are actually quite neat, and let's propose them and let's incorporate them into the language. And it was a very long and very exciting journey to get them approved into the spec of the language and into the compiler itself. And the problem that we had to overcome with effect handlers is that they're too clever. So people are scared of things that are too clever. With effect handlers, you can do things such as structured concurrency. You can implement probabilistic programming and automatic differentiation as libraries. So you can do like really, really sophisticated stuff. But all these things, there doesn't seem to be a lot of like meat and potato appetite, right? Like meat and potato programs that justify introducing this feature. But what does justify effect handlers in any programming language, and is something that it's used a lot in industrial programming, is dependency injection. I'm not going to explain to you what dependency injection is, but basically it lies at the heart of these things that are called software frameworks. And the difference between a framework and a library is that the program calls the library, but the framework calls the program. So it gives you they are kind of software architecture with inverted control. And these are very heavy going in using conventional programming languages, because the only real non-local control that you have is the function call, which goes in kind of down. But you want also something to go up into the context, and that is what effects do. And we could have a lot of really, really practical examples of using effect handlers for dependency injection and greatly simplify the code of many frameworks. From the point of view of an effect handler researcher, these are maybe disappointing applications because these are very simple compared to the power that effect handlers can unleash. But these simple applications are the ones that are really very exciting on a mass scale level. So we are very happy to have them in the language and to exploit them. Okay, so this is not the Epstein files. This is, I couldn't find another way to animate this. So some of the conclusions, some of the things that I learned using in an industrial research lab on a industrial project. So it's not a research project, it's something that's actually delivered to customers. And in fact, right now, some of the largest apps in China are being rewritten partially or completely in Cangjie. And what I noticed that when you work in an industrial lab, you have two kinds of innovation. You have top-down innovation and you have bottom-up innovation. And what do I mean by top-down and bottom-up? Here at the top, you have these people in suits. They are called executives and clients, and they have needs. And here at the bottom, you have researchers, like they're at the blackboard trying to figure things out. And research can happen and innovation can happen in two ways. It can be top-down, demanded by the people at the top, or bottom-up, proposed by the people at the bottom. And these two kinds of innovations are extremely different. The ones that come from the top is always urgent. It's always something that has to happen as soon as possible because otherwise the product will fail in the marketplace. But the bottom up is important. It includes significant innovations, not making it 5% different, but making it completely different. So the importance of the bottom up innovation is in some sense much higher, even though it's not urgent. But the top-down innovation can be evaluated quantitatively. There's a famous quote that I like a lot from Ford, the guy who invented the Model T. And he said, if I ask my customers what they want, is they would want a faster horse. These people at the top, they always want a faster horse. And you can tell my horse is 5% faster, and they're gonna just love it. It's like, wow, a 5% faster horse, amazing. Whereas the bottom-up innovation, because it involves doing things differently, is qualitative and very difficult to assess. As a result, the top-down innovation leads to immediate income, whereas the bottom-up innovation requires a lot of investment and a lot of patience to reach fruition. So the top-down innovation is always short-term because it can be short-term. It's about taking something that existed, making it better, whereas the bottom-up innovation is always long-term. And it's not long-term because it's harder to do. In fact, many times it's easier to do, but it's because the short-term top-down innovation, it's already applied to very complex systems. So the work is very challenging in terms of complexity. But the bottom-up innovation is just a different way of doing things. And it has to be long-term because it has to wait for its chance, for its opportunity to be successful. That's why the need for top-down innovation is always amplified from the top. The executives, the leaders of the company and the clients always want this top-down innovation, whereas the bottom-up innovation proposed by the researchers themselves is always disruptive. It always requires people to change the way they think, and that leads to resistance. The top-down innovation, if you can make that horse that they're riding 5% faster, it's going to be always welcome. Without exception, it's going to be very well rewarded. Whereas if you say, let's not use horses, let's invent these things called automobiles, that sounds like crazy to people who have never seen an automobile, because it just is so different that there's always going to be a lot of resistance. So for the top-down innovation, the organization itself works like a pump, more and more and more, whereas for the bottom-up innovation works like a filter. Only the most persuasive and opportune bottom-up innovation have the chance to succeed. So, for example, effect handlers is an example of bottom-up innovation. There's nobody in the leadership of the company or nobody in our client base who says we want effect handlers because they never heard of effect handlers. But they heard of dependency injection, and they can see when a solution of dependency injection is better, a lot better than the existing solution. To conclude, I want to say a few words about China because I had the pleasure to spend a lot of time in China, and I'm sure you have heard a lot of bad things about China. I don't know. I don't want to engage on a topic by topic basis, but you may believe that is some kind of nightmarish dystopia of various problems avalanching down towards catastrophe. Maybe it's true, maybe it's not. I don't know. But when you are there, definitely the impression that you have visiting its cities, interacting with its people, both the modern side of China and the historical side of China are fantastic. It is an affordable country. It's easy to travel around. Uh, it's always something to do, no matter what you're looking for. So, just kind of a collection of random pictures here. This is a Buddhist shrine in Shanghai. This is the research center in Shanghai, taken at street level, a picture taken by me. And maybe at street level is even more impressive, because here, as far as the eyes can see, this is the Shanghai Research Center, a modern neighborhood on the river in Shanghai, part of the Imperial Castle, the old Imperial Castle in Xi'an, old city center of Nanjing, lots of water, a forest restaurant in Hangzhou. Here are young people taking pictures of themselves in historical costumes on the city walls of Xi'an. This is a mosque in Xi'an. Xi'an, about a quarter of the old city, is a Muslim neighborhood with lots of mosques and lots of Muslim food, particularly lamb barbecue, a lot of it, and very cheap and delicious. The lake in Hangzhou and the hills in Hangzhou, a lot of food in China. People will be extremely excited and willing to introduce you to their local cuisine. Some old neighborhoods, occasionally preserved for mainly a lot of them for touristic potential, and then some and one of the new coffee chains. I like the name, the Algebraist. Seemed quite apt. Which again, you can have a very decent latte if that's what you're craving. So I spent a lot of time in China. I traveled to a lot of its cities, and if you have the opportunity to ever travel there, I recommend you don't hesitate. It's just waiting to be discovered. Thank you very much.
Thank you very much, Dan. Fascinating experience.
Yes, indeed.
So if anyone has any questions for Dan, we have plenty of time. You may raise your hand via the reaction panel, or simply shout out. I see. I'm not sure whether this was a bit of a rhetorical question, but Paul Taylor had asked on your slide about bottom up and top down. Dan, have you managed to get this message across to the pointy-haired bosses?
Yes. In fact, we had. In fact, this slide is the summary of a talk that I was. So there was recently, we had a meeting of various directors, and every director gave a presentation on various challenges or various aspects of their Huawei activity, which they thought interesting, worth sharing. And that's what I spoke about, my kind of experience at Huawei, speaking to other directors and to leaders of the company. Huawei is a very large company, and it's a network, not a pyramid. So the way there's no real pointy hair bosses. Every part of the organization has its own leaders, and every leader has its own influence. And a lot of the processes are fairly informal, and they involve a lot of discussion and negotiation until some kind of consensus emerges. there's both advantages and disadvantages to doing business this way, but I don't know. I mean, that's kind of beyond my. Let me delete this so you can actually see the text.
Done.
Yeah.
I want to kind of talk more about work, but I think Benedict has also got his hands up. So
Okay.
I'd like to go first. Benedict.
Thank you. Yes, it was just a slightly more technical question on the effect handlers. Were these multi-shot or one-shot or?
Good question. So right now they are single shot, and they are, but the implementation actually supports multi-shot. So we are not allowing the user to use them in a multi-shot way, but they could be used. It's just, again, the question is enabling such a feature, enabling multi-shot. Is it something that giving kind of that extra power to the user? Is it something that is going to allow them to build better things? Or is it something that is just going to unleash chaos? Are we just inventing the next go-to, basically? So that has to be, we have to show compelling examples and compelling practical examples, just like we had for dependency injection, where such multi-shot are actually required. I think we had some. I can't anticipate, but I think we have some. We have such examples. So I think multi-shot will be introduced at some point. My hope is.
And if I may just follow up briefly, is it also with an effect system? So is it tracking of effects, or are they like OCaml untracked?
They are untracked, and there is again, we would like them to be tracked, but again, the complications that they add to the type system. So right now, I think what we need to do is to see that effect handlers are used in substantial projects, and then the use in substantial project, hopefully in due course, is going to make the case for having an effect type system. But right now, we know how to do an effects type system. There's a lot of literature, and we know how to do it for Cangjie. But again, there's no strong motivation. But the language is open source, so anybody can add an effect type system and propose it and justify it. So because it's open source, anybody can contribute to it now.
Thank you.
Can I go now? I have a much older sort of question, which is that, for many, many years, people have said that string diagrams were not as good as lambda terms and stuff like that, because you have to introduce an extra layer of indirection in what you're doing. So how do you kind of deal with that to begin with? Or is it exactly this? I mean, I love the picture of the lion becoming a griffin because it is really cute. And I've seen this happening in my own life several times, right?
Yeah.
So the question is whether kind of the string diagrams were shunned because, you needed to kind of get things faster, more efficient.
I think that the string diagrams were, maybe there was a kind of a bad engineering decision to use them the way they were used. I think parsing, when you parse the code, I think it should go directly into a string diagram. I think having an abstract syntax tree is pointless. So I think the structure that should be used for parsing should be string diagrams. So when you parse your code and you construct a combinatorial data structure to process downstream, I don't think you should construct an AST in the first place. I think parsing can directly produce a string diagram or the graph concrete representation of a string diagram. And I don't think I can think of any instance where an abstract syntax tree, a conventional AST, would be superior to a string diagram from any
And can you
point of
point
view.
out to implementations that do that? Big implementation, not
What do you mean?
not toy. A kind of real language that use string diagrams directly for instead of ASTs.
Well, no, I think string diagrams are not a lot, they're not popular enough. So I think maybe there would have been an opportunity with our compiler if we would have made better choices. My hope is that at some point this compiler will be fully rewritten in order to make it self-hosted, so implement the compiler in the language itself. And hopefully then we will use from the get-go, we will use string diagrams instead of ASTs, and thus demonstrate that they are very useful, and then control flow analysis and other things in the next stage.
I see. Thank you.
Great, thank you, Dan. Are there any further questions from Dan from anyone? Okay, in that case, I think we'll thank our speaker again and end the discussion.
Thank you.
Ending
Thank you for
by-
having me. Thank you
Yes.
for having me. Bye.
Thanks very much, yeah. Everyone have a good week.
Bye-bye.